Hey y'all. Today's lesson is finding the area of triangles using trig. So we are specifically talking about non-right triangles. These triangles are sometimes referred to as oblique triangles. And what you need is two sides and the included angle of those two sides. If you have two sides of a triangle, so like A and B, and the included angle of C, that's what you need, and you can find the area. So here is the formula we're going to use. Area equals 1/2 A times B, and A and B are sides, lowercase a, lowercase b, times sine of C, the angle C. And from now on, when we draw triangles, the angles A, B, and C are going to be capital letters. They're going to be across from the little lowercase letter, which is the length. So angle A is across from side A. Angle C is across from side C, and angle B is across from side B. So that's the way that we're going to start denoting our triangles to make it just easier to understand and follow. So when you see A, B, and C, I'm just talking about two sides and an included angle. It might not always be A, B, and C. It could be A, C, and B, or it could be C, B, and angle A, but it's two sides and an included angle. So before I show you how to do it, I'm going to show you where it comes from, because I can just tell you this is the formula, but I want you to understand why. So here we have a triangle, and the area of a triangle is 1/2 base times height. We know that, half the base times the height. Now in this triangle, the base would be A. This is the base. So instead of B, it would be 1/2 A. But the height, the height has to be a 90-degree angle. We would know that the height would be this line right here. That would be H. But we don't know H. However, using our trig function, we know that we can find H from the perspective of angle C. So if we're looking from the perspective of angle C, we're trying to find H, and we have A, and we have, well, A goes all the way across. So we would need B, H and B. From the perspective of C, H is our opposite leg, and B is our hypotenuse, because here is your right angle. And so from the perspective, if we wanted to use the opposite and the hypotenuse, then we would use H equals, sine of C equals H over B. The opposite over the hypotenuse. So I'm using H as the height over B. That's our hypotenuse when we draw the height in. In our other triangle, it's not the hypotenuse because it's not our right triangle. So I have a trig function set up, but I want H. See, I want H. So I'm going to cross multiply, and I get B times sine of C equals 1 times H is H. So I cross multiply. B times this, 1 times this. So that means my H value is B times the sine of C. That is the height. If I wanted to figure out the height, I would type in B times the sine of C. That means it's B times the sine of C. And that is where the formula comes from, because I'm using my 1/2 base times height, but the height, we have to use that trig function in there. So this is where the formula comes from. Now to use it, the examples are pretty easy. You just put the numbers in and you solve. So I'm going to just do two examples with you. I have the formula, and I want to find the area of this triangle. So I start with 1/2. My A and B are my two sides. So I have 12 and I have 10. And then my sine of this angle, 50. Now when you type this in, don't forget to make sure that your calculator is on degrees. And you would type in 1/2 times 12 times 10 times sine of 50. And we would get 1/2 times 12 times 5 times sine of 50, and we would get 45.96 units, whatever this would be. So this is the area, units squared. So I don't know if it's inches or centimeters, but that's how you find the area. Let's do number 2 together. I've given you two sides and an included angle. So to find the area, it would be 1/2 times 9 times 7 times sine of 21 degrees. So I would type that in, 1/2 times 9 times 7 times sine of 21 degrees. And the area would be 11.29 units squared. So I know this was quick, but if you know this formula, when you have non-right triangles, that's how you find the area.